So the next examples we'll look at here. So number 4 says an offshore oil well is 3 kilometers off the coast, and the refinery is 8 more kilometers down the coast. And so it gives us a little bit of a ratio in terms of laying pipe in the ocean is more expensive than it is on land. How far from the refinery should the pipe meet the shoreline to minimize the cost? And so, so we're trying to figure out, where do we aim? Like, where should we aim? And you might say, well, you're trying to minimize, like the distance, the shortest distance is that. I agree, but that's minimizing distance. We're trying to minimize the cost. And so if you go in that direction, you have all of the distance in the water, which is twice or 2.5 times as expensive. If you go straight down across, that minimizes how much water you've got to travel, but then it also maximizes the total distance, because now you're traveling a total of 11 kilometers, both in the water and the land. So maybe there's a compromise, and that's sort of the whole point. Like, can we sort of maybe aim towards the refinery to try to minimize how much we're in the water, but then also try to minimize that total distance there. So that's sort of the idea here. Oops, I don't think that worked. Sorry. And so it might, I'm putting the question mark, like right here. But just for the sake of maybe this triangle, it might be easier to call this distance here x. So if this is 3 and this is x, then I know that this distance here could be thought of as the square root of x squared plus 3 squared, or x squared plus 9. And then this distance here could be thought of as 8 minus x. Right? Because if that's x, then that would be 8. Take that away. Now, so it says it's 2.5 times as expensive in the ocean than it is on land. So it's probably, so whatever it is going to charge per kilometer. And per meaning multiply. So if it's this many kilometers, you multiply by, let's say, I guess $100 per kilometer, then it'd be 100 times that. And then that would have been 2.5 times more than this. And so it doesn't really matter what the actual cost is. What matters, I should say for the unit rate, what matters is it's 2.5 times. So if I think about the distance in the water, so if I'm thinking about like my cost here, it's going to be the distance in the water, which is the square root of x squared plus 9 times the cost. So, excuse me, so we'll call it like 2.5 per unit. And, and that way I can call the other one just 1. So that would work. And then the distance here, 8 minus x. So this is this distance times its cost of 1. And again, it doesn't matter. Like, we could just say it's $1 for all we care, because as long, whatever you pick for that, just pick this to be 2.5 times greater. So there would represent a cost function in terms of x, in terms of where I'm going to put that particular spot. So if you wanted to multiply that out, there's not a whole lot you could do to simplify, but you could say your cost. Oops, sorry. I was on highlight. You could say your cost is equal to 2.5 square root of x squared plus 9 plus 8 minus x. So whatever that cost looks like, let's take its derivative and hope that there's a minimum value. And if there is, it would be where the derivative is equal to 0. So c prime is equal to, so 2.5 times 1 over 2 square root of x squared plus 9, because that's the derivative of a square root, times chain rule, 2x. That goes away, minus 1. So then we set this equal to 0. This 2 and this 2 would cancel. So we get 2.5x over the square root of x squared plus 9 minus 1. Now, this function is actually never undefined, because this is always positive. So then when we solve this, add the 1 over, so we get 2.5x over the square root of x squared plus 9. Multiply that across, and that 2.5, I'm going to think it was like 5 over 2x, if that's okay. Let's square both sides, right? because if we square both sides, that'll eliminate the square root. Square. So then so now we get x squared plus 9 equals 25/4 x squared. And then we can subtract this over. So 9 is equal to 21, excuse me, fourths x squared, because that's just like a 4/4, right? It's a 1. And then, solve for x squared. So multiply by 4 21sts, which is dividing by that reciprocal. So take that times 4 21sts. So that becomes 36/21 equals x squared. And then we square root that. So then x would equal the square root of 36. And we're introducing the square root, so it should be plus or minus. So we get plus or minus 6/√21. But we're realizing that x is a distance. And doesn't make sense to have a negative distance. So x is equal to 6 over the square root of 21 kilometers. Now, that's an important number, but it's not really the answer, because it says like how far from the refinery. In other words, we need to look at this distance here. But if you know x, we just subtract it. So that distance would be 8 minus 6/√21 kilometers. So that distance right there is where you should aim, or you just aim 6/√21 from there. Now, if it were root 16, that would have been 6/4, which is 1.5. So this is a little bit more than root 16. So this overall value would be a little bit less than 1.5 kilometers. So, okay. Now, let's do another one. This one deals with distance as well. So it says, find the point on this curve that is closest to the origin. So if I look at this graph, and not that you have to actually know how to graph it, but it helps. It's shifted to the left 5. I should say it helps in terms of visualize what's happening. Here's the origin. So the origin is 0, 0. And it looks like, again, maybe I just why I drew this, but like maybe like around here, at that point, x comma y, that looks like that might be the smallest distance. But what we need to do though is represent an equation that represents that distance, any point x, y on this curve to the origin. So that's distance formula. So distance equals square root of, well, generically speaking, or general speaking, it's x2 minus x1 squared plus y2 minus y1 squared. And then, well, that's x minus 0 squared, so that's nice. And then plus y minus 0 squared, which is also nice. And we then can actually even substitute this in for our y, because it's wanting an equation in one variable, not two. So this becomes x minus 0, which is just x squared, plus, and then, it's like 2 root x plus 5 minus 0 squared. And so then that's equal to the square root of x squared plus, well, I can square the 2, that's 4, square the square root, so that becomes x plus 5. And then you could distribute that so that we get our distance is equal to the square root of x squared plus 4x plus 5. Oh, sorry, plus 20. Now, that represents all possible distances. We want the minimum one, so we take the derivative. So then, might need to slide this guy down a little bit so I have some more space. So d prime, so d prime is equal to, remember, square root's derivative is 1/2 times that root of x squared plus 4x plus 20. And then times the chain rule, the derivative of the inner function, which would be 2x plus 4. And, I noticed that this 2 would cancel the 2 and the 4 to be like a 1-to-2 ratio. So my distance would be x plus 2 divided by the square root of x squared plus 4x plus 20. And we set that equal to 0. Now, again, thinking about when is this undefined? Well, it would be undefined when you are dividing by 0 or taking a square root of a negative, which actually ends up happening. You don't, which is great. So then we just solve it, and it's really easy once you realize just multiply this over. It still stays 0, so it's x plus 2, which means x is equal to negative 2. Now, I have to go back and read the question. It says, find the point on the curve. So if we know what x is negative 2, we also then can find the corresponding y value. So y is equal to 2 square root of negative 2 plus 5, which is 3. So y is equal to 2 square root of 3. So my coordinate then, that is closest, would be negative 2, comma, 2 root 3. And what would that distance be? Well, if you calculated what x was negative 2 into this formula here, it would tell you exactly what that distance is. Negative 2 squared is 4 minus 8 plus 20. So what is that? Negative 4 plus 20 is 16. It's the square root of 16, which is equal to 4. That's pretty impressive that it came out such a clean answer. So, okay, so and then again, there's be another video, and check out those those examples. And at any point in time, you could pause the video, try the problem, see how far you get, then resume the video, and help that could help you get into the next step of the problem.